to module 14.7. In this lecture video, I'm going to show you how to how to solve word problems involving with the work. Okay, called the work problem. All right. So basically, here's the idea. Okay, if it's going to take you 4 hours to paint a room. Okay, take you 4 hours total to paint a room. How much can you paint in 1 hour? Well, in 1 hour, you got to paint a fourth of the total job. Okay, you only paint a fourth of it. Okay, because if it takes you 4 hours to complete to painting a room, every hour you will actually paint 1/4. That 1/4 is basically your rate, how fast, okay, you working alone. So imagine working together with somebody else, okay? Imagine working together with somebody else. Of course, the two person working together is going to get a job done a little bit quicker, okay? So let's say it takes you 4 hours, it takes somebody else 6 hours to paint the same room. So in every hour, you paint 1/4, the other person paint 1/6. So that means working together, okay, working together, y'all can finish the job lesser than 4 hours. So the way how we set up these type of word problem is to put the time working together on the numerator, time one person work on the time each person work alone, put them in the denominator, and add them up together equal to 1, like a one job. Okay, so that's the way how we're gonna set it up. So let's translate. Okay, let's translate. Pam and Craig work together, can weed the garden in 6 hours. So this 6 hour means working together. So that will go on the numerator. So whenever you read the wording working together, there's always a fraction bar plus sign and a fraction bar equal to one job. The time working together goes on the top, which them two together can weed the garden in 6 hours. Working alone, Craig takes twice as long as Pam. So I'm comparing between Craig and Pam. All right, since Pam is listed at the end, then Pam will be X. Craig takes twice as long, so that will be 2X. Okay, that's the time Craig and Pam work alone. All right, so Craig takes twice as long, so that means Craig takes longer. Longer means slower, okay? Takes longer because it works slower. So make sure you understand that. So I'm gonna put Craig under the first 6 and Pam, X, put under the other one. All right, so that's how we set it up. Time one person, the time Craig work alone, and the other denominator will be the time Pam working alone. All right, let me put it right here. All right, let's solve for X. This is a rational equation. So I got denominator 2X and X. 2X means 2 times X. So when it comes to finding LCD, the X actually repeated because since both denominators are one term and one term, so if we count the repeated factor, X repeated, the 2 did not repeat, count that one time. So my LCD is 2X. Now we will multiply every term by 2X. Even the 1. 1 is a term, got to times 2X. So when I times 2X, means 2X over 1. All right. So the top 2X, bottom 2X canceled out. That just leave me with 6 plus top X, bottom X canceled out. That leave me with 2 times 6, which is 12, equal to 2X. All right, so combined like term, this is a linear equation. So that's 18 equal to 2x, x equal to 9. So how long does it take Pam to weed the garden alone? So it will take Pam 9 hours to work alone. Okay, that's all we have to do. Working together, put the time working together on the numerator, and the time working alone goes in the denominator. All right, this problem, for example, if Rachel were painting her living room alone, it would take 4 hours. So Rachel will take 4 hours. Let's put Rachel down here. Her sister Terry could do the same job in 6 hours. So that would be Terry 6. How long would it take them working together? So my variable x got to represent the time working together. All right. So this is no longer a rational equation because there's no variable in the denominator. Denominator are not polynomials. So I'm just gonna solve this regularly. Okay. I'm still gonna clear the fraction. The LCD between 4 and 6 is gonna be 12. So multiply every term by 12. All right. Top 12, bottom 4 reduce into 1 and 3. 3 times x, 3x. This is actually a linear equation. All right. Top 12, bottom 6 cancel out into 1 and 2. 2 times x, 2x equal to 1 times 12 is 12. So this is going to be 5x equal to 12. X equal to 12 over 5. All right. So how long will it take them working together? If needed, submit your answer as a fraction, reduced to the lowest term. So it will take them 12 over 5 hours to work alone, which is a little bit over 2 hours. All right, one of my favorite questions in this particular module 14.7 is the pool question. It's kind of a strange problem. An inlet pipe on a swimming pool can be used to fill the pool in 24 hours. The drain pipe can be used to empty the pool in 40 hours. Okay, so what that means so far is the water is going into the pool faster than it can drain out. That's a very important concept because I tell you that even with the drain open, because the water is coming in at a faster rate, okay, then it can drain out. Eventually the pool will still be filled up even with the drain opening. So let's say if the pool is already 2/3 filled and then the inlet pipe and drain pipe are suddenly opened, how long will it take? How long from that time it will take to fill the pool? Okay. So let's think about this, okay? I'm adding water in faster than it will drain. All right, so let's assuming the two pipe working together, time work together, and let's assume the pool is completely empty, okay? Because the 24-hour means it actually filled up while the pool is empty. And the 40-hour draining is assuming the pool is actually completely full. Now, because we can fill the pool faster, so the water coming in got to go first because we're coming in faster than we're going out. So let's put draining here. Time working alone go in the bottom, together equal to 1 job. All right, but this time we're not adding. We're actually working against each other. All right, so water coming in and then water going out. So here we got to subtract. Okay, because we're working kind of against each other. So let's say the time working together is X. Out of 24 hours coming in, working alone, minus, okay, the time working together divided by the time draining alone, together equal to 1 job. All right, so let's see. My LCD between 24 and 40, or we can do it this way. I'm going to show you a different way to do it. Rather than finding LCD, we're just going to treat this like a linear equation, that's what they are. This is 1 over 24 minus 1 over 40. 1 over 24 minus 1 over 40. Convert to a fraction, that's actually 1 over 60x is equal to 1 joule. All right, divide both sides by 1 over 60. 1 divided by parenthesis 1 over 60. All right, that means it will take 60 hours, okay, to work together. All right. So this 60 means 60 hours to work together to actually fill the pool when it was empty. All right. So if the pool is 2/3 filled already, that means it only need to go another third of a way to fill the pool. So since the pool, when it was empty, it takes 60 hours for them to work together, then if I only need to fill the remaining 1/3 of the pool, so that will be 1/3 times 60, which will only take the 2 pipe 20 hours to fill out the pool when it was already 2/3 full. Okay, so that's the way how this problem works. All right, so real quick, 3 examples on the application of rational equation involving with the work. All right, that will conclude this lecture video. Thank you for watching.